Hi, today we're doing another form of estimation called the trapezoidal rule. What we did before with Riemann sums created these rectangles, and well, as you can tell here, there's a lot of area that gets left out when we did just rectangles. When we do trapezoidal rule, we'll use these yellow rectangles, but they're not rectangles anymore. They're trapezoids. Instead of going straight across, I'm going to go at an angle, almost like I'm making a secant line to the curve right there. And it gives us a lot better approximation because this area ends up being canceled out, or we are now adding it and getting it a better approximation because we're getting closer. So how we're going to use it, let's say we want to find estimate the area of this using 4 intervals using the trapezoidal rule. So what we're going to do is we're going to be making a table. We're going to need to make a table from x, and then we need a table with f of x. What we're going to say is, if I'm going from 0 to 2, that means what is my width of each interval. In this case, that would be what my height of, in my area formula would be, is the width between them. If I go from 0 to 2 with 4 intervals, well, the way to find that is I would subtract to go 2 minus 0, then divide by my intervals. So my height would have to be 1/2 for each. And then to find the bases for each, the bases I'm going to be using f of x to find that. So what I mean by that is, when I go and fill this table, if I'm going from 0 to 2, I got to start at 0, and I'm counting by 1/2 each time. 1/2, 1, 3 halves, and 2. And then to find f of x, this is my f of x right here, x squared. 0 squared is 0, 1/2 squared is 1/4, 1 squared is 1. This will become 9/4, and this will become 4. If you want it as decimals, this would be 0.25, and this would be 2.25. That's easier for you. So now, what we're going to do, 4 intervals. That means I'm going to have 4 trapezoids here in the end. What I'm going to have, the first one will be using these 2 f of x values as my bases. So that means I'm going to have, the area is 1/2 times adding the bases, 0 plus 0.25, times the height. The height is my distance between, which we said was 1/2. And when I multiply that, I should get 0.0625 for that. Next, what I'm going to do will be for these 2, the 1/2 and 1. I still have a width of 1/2. My bases now are the 1/4 and 1, still 1/2 here. And this ends up coming out as 0.3125. The next one on my list here would be the 1 and 3 halves. Again, the 1/2s are the same. We got to check what's in the middle. It's going to be 1 plus 2.25. Multiply that out, I should get 0.8125. And then for my last one here, that should be doing 2.25 and 4, 2.25 and 4, and I multiply by 1/2 on either side as well. And that one should come out as 1.5625. And then my answer, in the end, is just if I added all these up. And when I do, I should get 2.75 as my answer. Now, this can end up getting a little bit tedious. There's just a lot going on here. I want to give another option if you prefer. Some do, some don't. This is another way that you could have attacked this. If I'm multiplying each of these by 1/2, and then multiplying it by another number, 1/2 again, well, what I can do is I can say I'm going to pull all those out front. Multiply by 1/2, then multiply by 1/2. And then all these in the middle would be what I would add up. And we'll notice what happens. All of them are done twice, except for my 2 end numbers. So what I would do is I would do my end number first, then I would need 2 times my next number, 2 times the next number, so 2 times 1, 2 times this next number, 2 times 2.25, and then now 1 of my last number. So again, the first one's only once, the last one is only once, all the ones in between are multiplied by 2. And then if I were to multiply that out, it would be 2.75. This looks a lot simpler, but there's a lot more ways that you can mess up that way. If you do this, at least you're certain that you're doing each trapezoid correct. I don't care which way you go about it. Each of them works just fine. It's whatever works better for you.